Good evening. We start with sum number 8. Before that, let us revise formulae for shift of origin. Can be remembered easily. Small x is capital X plus h. Small y is capital Y plus k. Means what? Old coordinate. Old coordinate is new coordinate plus coordinate of shifted origin. So h comma k are coordinates of shifted origin. Small xy are old coordinates. Point is the same, but with respect to new axis, capital XY are nothing but new coordinates. Sum number 8 from exercise 5.1. If the origin is shifted to the point O dash 1 3, the axis remaining parallel to the original axis, find the old coordinates of the points. Means we are given new coordinates. They are 5 4 and 3 3. Right down. You should always begin with formulae for shift of origin R, or just write down shift of origin formulae R. Shift of origin formulae are small x equal to, write down, capital X plus h, small y equal to capital Y plus k, and you should explain where small xy old coordinates, capital X capital Y new coordinates, and hk shifted origin. Now origin is shifted to which point? Here hk, the point is given to be 1 3, right now. Therefore small x is capital X plus 1 and small y is capital Y plus 3. So first part, C capital XY is given to be what? 5 4. So it is small x capital X plus 1, that is 5 plus 1 equal to 6. Find out. Small y capital Y plus 3, so 4 plus 3 equal to 7. So what are the old coordinates? Old coordinates are 6 7. Okay, so this is the first part. See, only you have to substitute the values. Now dxy new coordinates. What are the new coordinates? 3 3. So it is small x. It is 3 plus 1 equal to 4. Right? And what is small y? 3 plus 3 equal to 6. What is asked? Old coordinates. So old coordinates are 4 6. Old coordinates are 4 6. Right now. Sum number 9 now. If the coordinates A 5 14 change to B 8 3 by shift of origin, find the coordinates of the point where origin is shifted. Simple one. Right done. Shift of origin formulae are, shift of origin formulae are, right done. Small x is capital X plus h and small y is capital Y plus k. Rearrange the terms. Here x y old coordinates. Now they say that coordinates 514 change to 83. So small xy, old coordinates must be what? 514, simple. And new coordinates, see, point doesn't move anywhere, origin is shifted. So what are the new coordinates? They are 8 3. So only substitution is there. Right down. Therefore, what is h? H is nothing but 5 minus 8, that is minus 3. And what is k? K is nothing but 14 minus 3, that is 11. Therefore, shifted origin h comma k is what? It is minus 3 comma 11. Yes, that is the answer. Right on. Sum number 10. Obtain the new equations of the following loci if the origin is shifted to the point O dash 2 2, the direction of axis remaining the same. Okay. See, first A part is for homework. I'll just give the answer. It is simple one. It is 3x minus y plus 6 equal to 0. Okay. So A is for homework. We start with sum number B. Write down. Formulae for shift of origin are, write down. Formulae for shift of origin are small x equal to capital X plus h, small y equal to capital Y plus k. Here shifted origin, is hk, which is given to be what? 2 2. Therefore, small x equal to capital X plus 2 and small y equal to what? Capital Y plus 2. So this is number 1. Write down. Locus is means original equation. We are doing B part. Locus is x square plus y square minus 3x equal to what? 7. Therefore, now replace small x by what? Capital X. So capital X plus 2 bracket square, capital Y plus 2 bracket square, minus 3 capital X plus 2 equal to 7. Reason from 1. Now simplify this and tell me what is the answer. So x square plus 4x plus 4 plus y square plus 4y plus 4 minus 3x minus 6 minus 7 equal to 0. Therefore, capital X square plus capital Y square plus x plus 4y minus it will be what? Minus 5 equal to 0. This is new equation. Now let me explain. Usually final answer is written in the form of small x and small y, which are called as current coordinates. But in some colleges they say that this should be the final answer. Okay, so accordingly you have to write the final answer. But here I will say replace xy by small xy to get x square plus y square plus x plus 4y minus 5 equal to 0, right? But in exam, write this answer as the final answer. So this is about B part. Okay. We'll be doing C part. Again, D part for homework. C part, this is the old equation. Now from 1, what is small x? Capital X plus 2. Small y, capital Y plus 2. Replace small x, small y by these. Simplify, you get xy equal to 0. See, in 12th standard, we are going to discuss one topic, that is pair of lines. So we will see that xy equal to 0 is the joint equation of coordinate axis, because x equal to 0 is y axis and y equal to 0 is nothing but x axis. So this is C part. Now D for homework. Let me tell you the answer. Answer is y square minus 4x equal to 0. This is for homework. Write down. Now we discuss an important concept, that is inclination of a line. Suppose line L, I have taken line L which is not parallel to the x-axis, but it can be parallel to x-axis. Suppose line L meets the x-axis in the point, say A, in the point A, then the measure of the smallest non-negative angle, see, measure of the smallest non-negative angle made by the line with positive direction of x-axis is called as inclination of the line L, which is usually denoted by theta. So what is inclination of a line? It is angle made by the line with positive direction of x-axis. If theta is the inclination of a line, then 0 degree less than or equal to theta less than 180 degrees. Or I can say same thing using radian measure, 0 less than or equal to theta less than pi. Once again, I will repeat the definition. What is inclination of a line? Angle made by the line with positive direction of x-axis is called as inclination of a line. It is usually denoted by theta, 0 degree less than or equal to theta less than 180 degrees. What will be the inclination of y-axis? 90 degrees. So I can say inclination of y-axis, or for that matter any line parallel to the y-axis, is pi by 2, that is 90 degrees, right? What is the inclination of x-axis? 0 degree. Or even if a line is parallel to the x-axis, then also its inclination is nothing but 0 degree. Now we define slope of a line. Actually, slope of a line can be defined using two different ways. I will use concept of inclination to define the slope. After that, I will tell you how to obtain the slope of a line if any 2 points on the line are known. See, what is the definition of slope? If the inclination of a line is theta, theta not equal to pi by 2, then tan theta is defined as the slope of the line, which is also called as gradient, Gradient. Slope of a line is usually denoted by small m, right? So if theta is the inclination of a line, then slope of that line is m equal to tan theta, provided theta not equal to pi by 2. Why? Because if theta is pi by 2, tan theta is not defined. Okay, and that is why we say that y-axis has no slope. We will discuss that. What is the inclination of x-axis or a line parallel to x-axis? 0 degree. So what is the slope of x-axis or a line parallel to x-axis? It is nothing but tan 0 degree, which is 0. What is the inclination of y-axis? 90 degrees. So what is the slope of y-axis? Tan 90 degrees, which is not defined. And therefore we say that y-axis has no slope, right? And therefore, if a line is parallel to the y-axis, then also it has no slope. Now, can you tell me slope of a line which bisects angles in first and third quadrants? See, this is the line which bisects angle in the first and third quadrant. Its inclination is what? 45 degrees. So, slope is tan 45 degrees, which is nothing but 1. Similarly, what is slope of a line which bisects the angles in second and fourth quadrants? Its inclination is 90 degrees plus 45 degrees, that is 135 degrees. So slope is tan 135 degrees. You should be able to find tan 135 immediately. It is -1. Okay. So slope of line bisecting angles in second and fourth quadrants is nothing but tan 135 degrees, which is -1. Now we obtain slope of a line passing through given points, two distinct points, because two distinct points determine a line. If I say that line passes through x1, y1, find its slope. There are infinitely many lines which pass through x1, y1, right? And therefore, we should know 2 points on the line. Now the definition is, if a x1 y1 and b x2 y2 are any 2 points on the line, then slope of the line is defined to be difference in y coordinates upon difference in x coordinates, provided denominator is not equal to 0. I repeat, slope equal to m equal to what? Difference in y coordinates upon difference in x coordinates. Let us verify this, because we know that slope of x-axis is 0 and y-axis has no slope. So let us verify these two results. For that, I have to take any 2 points on x-axis. I can say this is 30 and this is 50. If you don't like 3050, take 3000 5000. Okay. So what is the slope of x-axis? Difference in y coordinates, 0 minus 0, that is 0, upon 5 minus 3 or 3 minus 5. Same thing. I'll do 5 minus 3, that is 2. 0 upon non-zero equal to 0. Yes. What is the slope of x-axis? It is nothing but 0. We have already obtained slope of x-axis. How? Slope is nothing but tangent of its inclination. Inclination of x-axis equal to 0 degree. Slope is tan 0, which is 0. Let us consider any 2 points on y-axis. Suppose this point is again 0, 3 and this point is 0, 4. You can take 1 point as origin because y-axis passes through origin. You can take 1 point on negative y-axis also. So in this case, what is slope? Difference in y coordinates, so 4 minus 3, upon difference in x coordinates, 1 upon 0, not defined. Yes, y-axis has no slope. Is that clear? So this is how we have verified that slope of a line passing through any 2 points ax1 y1 and bx2 y2 is given by difference in y coordinates upon difference in x coordinates. That is y2 minus y1 upon x2 minus x1. You can say y1 minus y2, but in that case, what will be denominator? X1 minus x2. Now we will prove that tan theta, see, we obtained slope using two different methods. Slope is tan theta, whereas theta is inclination of a line. If line passes through x1 y1 and x2 y2, slope is what? Y2 minus y1 upon x2 minus x1. In fact, it is always defined as rise upon run. In many textbooks, you will find the definition of slope as what? Rise upon run. Now, I'll explain that. So, we will prove that tan theta is y2 minus y1 upon x2 minus x1. Okay. Now, this is the line L which has an inclination theta. So, slope is tan theta. Now this line passes through the points A x1 y1 and B x2 y2. See what I have done. From A, I have drawn perpendiculars of perpendicular A1, and I have named this point, but this is say A2. This is perpendicular on y-axis. From the point B, I have drawn perpendicular BB1 on x-axis, right? Now AB2 is parallel to x-axis, right? So clearly this triangle ABB2 is a right triangle. Now these two parallel lines, x-axis and line AB2, these parallel lines are cut by the transversal L, line L. So these two angles are corresponding angles, they are equal, right? Now in right triangle ABB2, what is tan theta? Tan theta is opposite side BB2 upon adjacent side AB2. Note that BB2 is nothing but BB1 less B2B1. I repeat, tan theta is BB2 upon AB2. Now it is BB2, it is BB1 less B2B1. Actually, we have done this yesterday only while explaining the proof of shift of origin. What is B1? Distance of the point B from x-axis, which is y coordinate of B, y2, less B2B1. B2B1 is nothing but AA1, opposite sides of rectangle. Now AA1 is the distance of the point A from x-axis, which is y coordinate of A, y1, so y2 minus y1. Similarly, by drawing perpendiculars on y-axis, we can prove that this distance AB2 is nothing but this is origin OB1, which is x coordinate of B, x2 minus OA1, which is x coordinate of A, that is x1. I hope you understood this. If not, just remember the result that tan theta, that is slope, is y2 minus y1 upon x2 minus x1. So this is rise. See, BB2 is rise and this is run. So rise upon run is nothing but slope of a line. So write down this. Slope is m equal to tan theta. Theta is inclination. Theta, for theta 0 less than or equal to theta less than pi, theta not equal to pi by 2. If AB x1 y1 x2 y2 lie on the line, then slope of that line is difference in y coordinates upon difference in x coordinates, that is y2 minus y1 upon x2 minus x1. Of course, denominator cannot be 0. So what is slope of a line? It is usually denoted by m. So m is tan theta, which is y2 minus y1 upon x2 minus x1. Now we discuss intercept of a line. Suppose line, say L, line L cuts x-axis in the point. Actually, I should have denoted that point by A0. So this point is A0 and this is 0B. So line cuts x-axis in the point A0 and y-axis in the point 0B. Okay. So in this case, we say that A, small a, is what? X-intercept. Small a is x-intercept. And what is small b? It is nothing but y-intercept. I repeat, suppose line L cuts x-axis in the point A, capital A, with coordinates a comma 0, because if a point lies on x-axis, its y coordinate is 0, right? Then we say that A, small a, is x-intercept of the line, or the intercept made by the line on the x-axis is small a. Now this line is cutting y-axis in which point? B, 0B. So small b is called as y-intercept. Note that if I ask you what is length of the x-intercept, then it is not a, it is mod a, because a is just coordinate. If a is -3, will you say length of the x-intercept is -3? No, In that case, you have to consider mod A. So mod A and mod B are the lengths of the intercepts made by the line on coordinate axis. Now exercise 5.2. First sum, find the slope of each of the following lines which passes through the points. A part, A 2 minus 1, B 4 3. So it is better we write slope equal to y2 minus y1 upon x2 minus x1. At least for first few sums, write this y2 minus y1 upon x2 minus x1. So 3 minus minus 1 upon 4 minus 2. You can also say that minus 1 minus 3 upon 2 minus 4, same thing. So this is 4 upon 2, which is nothing but 2. So what is the slope of the line? Slope of the line is nothing but 2. So this is the first sum. Now what about second? We'll be doing all the four sums. The points are given to be minus 2, 3 and D 5, 7. So slope of line CD same as line DC. Write the formula y2 minus y1 upon x2 minus x1. So 7 minus 3 upon 5 minus minus 2, that is 5 plus 2. So 4 upon 7 is the slope. Find out for remaining lines, line EF and line GH. Second, if the x and y intercepts of the line L are 2 and 3 respectively, then find the slope of the line. As intercepts are A equal to 2, B equal to 3, line passes through which points? Line passes through A 2 0 and B 0 3. This is the definition of intercept. Therefore, what is the slope of line? y2 minus y1 upon x2 minus x1, 3 minus 0 upon 2 minus 0, that is 3 upon 2. See, you can also say 0 minus 3 upon 1 minute. Actually, denominator should be what? I'm sorry. y2 minus y1. So 3 minus 0, denominator should be 0 minus 2. Okay. So minus 3 upon 2. You can also say that slope is what? Instead of 3 minus 0, 0 minus 3. But in that case, what will be denominator? 2 minus 0. Same thing. So this is for second sum. See, try to draw the rough sketch also. Now slope is negative. So we expect that inclination of a line is an obtuse angle, because for an acute angle, tangent ratio is positive. Here slope, that is tan theta, is negative. So we expect inclination of line to be an obtuse angle. Check this. Yes. See, this is the point say 2 0. This is the point say 0 3. Yes. In exam, diagram is not required. But this is for our understanding purpose. Okay. Yes. So this is the second part. Now what about third? All these are simple sums. Find the slope of line whose inclination is 30. Theta is 30. I should say 30 degree, because if I say inclination is 30, that is absurd. 30 means 30 radian. So what is slope? Slope, every time you have to say slope of a line is tangent of its inclination. Tan 30 degrees. Immediately you should be able to write 1 upon root 3. There are many students who take 30-35 seconds to find tan 30 degrees. You're out of competition. So third one followed by fourth. Inclination is pi by 4. Similar sum. Theta is pi by 4. Therefore, slope of line is tangent of its inclination. So tan pi by 4. What is tan pi by 4? Tan pi by 4 is 1. Sum number 5. We'll be doing two more sums and then we'll stop. Sum number 5. A line makes intercepts 3 and 3 on the coordinate axis. Find the inclination of the line. Very good. Good sum. In fact, uh, we can obtain graphical solution also. See, this is 1, 2, 3, 1, 2, 3, not to the scale. Now, this is the line. I will say this is a straight line, right? So this is right isosceles triangle. Do you agree with me? So this is 45. So this has to be 135. Now you will ask me, sir, in exam, can we use this method? The answer is no. Then see, as intercepts, write down, as intercepts are 3 points A 30 and B 03 lie on line, or you may say line passes through this point, same thing, lie on line. Therefore, slope is nothing but y2 minus y1, that is 3 minus 0, upon x2 minus x1, 0 minus 3, that is minus 1, equal to tan theta 0 degree less than or equal to theta less than 180 degree. Okay. So the next step, this is nothing but tan 135 degree. Why tan 35 is minus 1? So theta is inclination, I'll explain that, equal to 135 degree. You can convert this to radian also. So that is what? 3 pi upon 4. Now what is the reason? If somebody asks you why tan 135 is 1, what is 135? 180 minus 45. Tan of, see, allied angles, that is very important. Tan of 180 minus theta is minus tan theta. So 135 is supplement of 45. What is tan of 180 minus 45? Minus tan 45. Yes, minus 1. So what is the inclination? 3 pi upon 4. Now we will discuss parallel and perpendicular lines. We will prove that parallel lines have the same slopes and product of slopes of two perpendicular lines is what? Minus 1. This is interesting. See, these are the two parallel lines. If their inclinations are theta 1 and theta 2, then clearly theta 1 equal to theta 2. So tan theta 1 is tan theta 2. That is m1 equal to m2. So we have to say that parallel lines have the same slopes. And if slopes of two lines are equal, then lines are parallel. Or we can also say that if slopes of two lines are not defined, then also they are parallel. Why? Because in that case, when I say slope is not defined, it is either y-axis or a line parallel to it. Okay, so this is the first part. Second part is interesting. We will prove that product of slopes of two perpendicular lines is minus 1. This is very important result. Product of slopes of two perpendicular lines is minus 1. And conversely, see, these are the two lines having inclinations theta 1 and theta 2. This angle, by theta we mean acute angle. Okay, so in that case we consider it supplement because it can be seen that this theta is an obtuse angle. Okay, and if I am interested in acute angle, then I have to consider its supplement. Now, what is the relation between theta 1, theta and theta 2? Measure of an exterior angle is sum of the measures of its remote interior angles. So what is theta 1? It is theta 2 plus theta. So what is theta? It is theta 1 minus theta 2. If two angles are equal, their tangent ratios are equal, right? So what is tan theta? It is tan of, now I will omit this step, tan of theta 1 minus theta 2. Use the formula. It is tan theta 1 minus tan theta 2 upon 1 plus tan theta 1 into tan theta 2. Okay. Now tan theta 1 is m1, slope of the first line. And what is tan theta 2? m2. So this is m1 minus m2 upon 1 plus m1 m2. But I am interested in what? I am interested in acute angle. So I am not interested in tan theta. I am interested in tan of pi minus theta, right? But what is tan of 180? That is pi minus theta, minus tan theta. So it is minus tan theta, that is minus in bracket m1 minus m2 upon 1 plus m1 m2, right? But if I consider these diagrams, this is not at all difficult. Then I am interested in this theta, which in this case is acute. So in that case, formula will be what? m1 minus m2 upon 1 plus m1 m2. And therefore, to avoid the confusion, we say that what is tan theta? Tan theta is nothing but mod of m1 minus m2 upon 1 plus m1 m2. Why mod? I repeat, why modulus? Because if theta is acute, tan theta is always positive. So 1 plus m1 into m2. In fact, I have obtained the formula for angle between two lines. Now, if lines are perpendicular, then 1 plus m1 m2 will be 0. Why? Because tan 90 degrees is not defined, because sin 90 it is 1 and cos 90 is 0. So 1 plus m1 m2 is 0. That is m1 m2 is nothing but minus 1. Okay, so product of slopes of two perpendicular lines is minus 1. Now some students may take objection, sir, you are saying that formula for tan theta can be used if theta is not equal to 90 degrees. So how come you are using this formula and saying theta equal to 90 degrees? Okay, no problem. I will use another method. Let me explain. See, this is theta 1, this is theta 2. Now these are at right angles. I hope this is you will agree with this. So what is theta 1? It is 90 degrees plus theta 2. Simple. Take tangent ratio. So what is tan theta 1? It is tan of 90 plus theta 2. Tan of 90 plus theta is minus cot theta. But what is cot? It is 1 upon tan. So minus 1 upon tan theta 2. But tan theta 1 is m1 minus 1 upon m2. Yes, cross multiplication gives m1 m2 equal to minus 1. I hope that you will appreciate this. So product of slopes of two perpendicular lines is always minus 1. So if we know slope of one line, then we can easily find slope of the line which is perpendicular to it. Okay. So actually we have to consider one more case. Suppose slope of one line is 0 and slope of other line is not defined, then also lines are perpendicular. Why? Because slope is not defined means line is parallel to y-axis. Slope of other line is 0 means it is parallel to x-axis. Then also those lines are perpendicular to each other. Okay. So at present just remember that if lines are parallel, their slopes are equal, and conversely, and product of slopes of two perpendicular lines is minus 1. That is, if lines are perpendicular, product of their slopes is minus 1. and if product of slopes of two lines is -1, lines are perpendicular to each other. In the next lecture, we will again discuss why tan theta is mod of m1 minus m2 upon 1 plus m1 m2, where m1 m2 are the slopes of the two lines and theta is an acute angle between them.